Hello everyone, welcome to this Markforged webinar. My name is Daniel Young and I'm the lead content engineer here at Markforged. Before we get started, I wanted to let you know that today is going to be a little bit different than your typical presentation. Instead of giving a PowerPoint and kind of talking about concepts, we're going to be interviewing one of our customers. The customer is Chris Sullenberger of the company Humanetics. Humanetics is a leading manufacturer of crash test dummies, and with that, I'll let Chris take it away.
Hi, my name's Chris Sullenberger. I'm a senior design engineer and a 3D print manager at Humanetics ATD. We make crash test dummies, which is we make them not only for the automotive industry, we also make them for the military and the aerospace industry. I'm a senior design engineer. I've been here for 12 years.
All right, cool. So, with your experience here at Humanetics, had you used 3D printing before coming across Markforged?
We started out shortly after I got here. We bought a Z Corp powder printer, and we mainly bought it to be able to do in-house silicone molds. From there, we've expanded into multiple plastic printers. We now currently have five different 3D printers, four of which are plastic, and we still have a 3D systems.
Before you bought the Markforged machine, or before you invested in that, did you have any preconceptions or thoughts about how 3D printing worked in the manufacturing environment?
I did not. When we first got our powder printer, 3D printing was all brand new to me. And over the last 11 years, I've pretty much learned more than what I thought I would ever know about 3D printing.
What are some of the things you learned from like the powder printers and using these existing machines?
It's amazing to see how much the technology has come along in just 10 years. And even now, looking at it, it's amazing within the last 2 years how much technology has changed. Back when we started with the 3D printers, it was the cost of decent 3D printers for a small company made it that we couldn't really afford it. Now the prices have come down, the technology has gotten so much better that almost any company can afford to have a 3D printer.
That's awesome. So I guess you had some experience before finding out of Markforged. What about Markforged particularly interested you?
We had a project that we were working on, and we were trying to use plastic printed, basically make an entire product out of 3D printed materials. We were able to do that. The problem was we could not get the durability that we were looking for, and when we came across Markforged with the ability to add the carbon fiber and the Kevlar thread into the plastic, we decided to have some samples made because we thought that would solve our durability issue. And after receiving the samples and doing some fine tuning on them, we found out that this was the way to go. And after making about 5 or 6 prototype parts, we were pretty much sold on the fact that we needed to buy a Markforged printer.
And so what were some of these prototype parts you were working on?
They were actually ribs for the dummy, and the ribs are one of the parts in the dummy that see some of the highest stresses during a crash. And what we found was that the plastic printed ribs from the other machine that we had used, they held up, but they would only hold up for about 19 or 20 impacts, and then they would start to break. And when we found Markforged with the ability to put the Kevlar thread in with the plastic, we thought, we've used Kevlar in other parts around here, so we know how strong Kevlar is. And we thought, well, if you can put Kevlar in with plastic, this should be exactly what we're looking for. So we went out and found somebody who had one of the machines that were willing to make us some sample parts. We had sample parts made and tested them and realized pretty quick that this was the way we needed to go.
Once you got the printer, what was the learning curve like? You had some previous experience with printers, but maybe fewer FDM printers. So how was ramping up with the Markforged machine?
Actually, yeah, the Markforged it was funny enough, the Markforged, the FDM technology, this was the first machine I had ever actually used with the FDM technology. But just knowing how the other 3D printers, the concept of 3D printing, the learning curve was very minimal. I mean, within probably the first week, I was pretty much ready to go and ready to make parts. I mean, yes, there are some tricks that you learn over time, but I mean, the basic out of the box learning curve is probably under a week, I would say, if you're familiar with 3D printing.
Absolutely. And so with that, like you've had the printer for roughly a year. How many parts would you say you've printed, just a rough estimate?
Oh, probably, I don't know the exact number, but I'm thinking it's probably around 150.
Mm-hmm. And so with these, are you primarily looking to use them in that existing operation with the ribs, or are you kind of branched out a little bit since?
Oh no, we've branched out. The original intent was we were going to make the ribs out of it. The problem was some of the other plastic parts that we had made that weren't ribs. We found durability issues with those, so we went back and ended up making those out of the Markforged printer and found that solved more durability issues. Mm-hmm. Then from there we've started looking at, we do a lot of molding in house, and we have a lot of silicone molds which over time wear out and have to constantly be replaced. So I decided to start looking at possibly doing molds out of the Markforged printer rather than the management wanted to go out and have aluminum molds machined, and I had suggested that before we do that, we take a look at the Markforged to see can we make molds cheaper in-house than having them outsourced and having them made out of aluminum.
All right, so you talked a little bit about silicone molds. Can you tell me a little bit about that process?
The way we currently would make silicone molds is we would use our powder printer, and we would design the mold and basically print the inverse of the mold out of the powder printer. We would then mix the silicone, pour it in, and then break the powder away, and you're left with the silicone mold. The silicone molds we mainly use for thermoset parts. They have to go into the oven. They have to be heated at around 220 degrees, and some of them have to be able to withstand that temperature up to 36 hours because of the parts that are poured have to post-cure in the mold because of the shape and the thickness of the parts. And what we were concerned about with the Markforged was whether or not the material would be able to withstand those same temperatures.
So what did you find out when you started to test these higher temperature applications for the machine?
We found out that we don't have any issues. We don't seem to have any heat or heat deflection of the material at the temperatures we're running at. So then it was, after looking at that, we decided, okay, now we know that the mold's going to withstand the temperatures in the oven. Now can we design a rigid mold to get a rigid part out of it?
And so what are some of the challenges with that rigid mold design? Because the one plus of silicone is that it's flexible.
Exactly, and the challenges with a rigid part and a rigid mold is you really have to pay attention to how you split your mold apart to make sure if you have any type of undercuts or anything that you can get your part out of the mold after you take it apart.
So how many silicone molds do you have in-house now, and how many are you looking to print?
We've got a combination of molds. We got some silicone molds, we have some aluminum molds, we have some molds that are perfect tool, which is kind of a hard resin type material. I would say silicone molds, there's probably over 100. The perfect tool molds, there's probably 40 or 50 of those, and pretty much all of those at some point are going to need to be replaced, and we're looking to replace as many of those with 3D printed molds as possible.
And so with that, I kind of want to dive into a couple parts that you've brought here today. First, since we've been talking about thermoset molds, I guess we'll talk about this thermoset mold here. For the audience here, can you kind of describe what we're looking at?
What we have here, it's actually a neck ring mold, and what it is it's a not a very large, it's a larger surface area, but a very low volume part that mounts to the underside of a head that goes on one of our dummies. What it does is it has a piece of neoprene that's attached to it for when they're putting the dummy into a car crash. The neoprene tucks down inside the suit so that all the glass and all the pieces that break off in a crash do not end up getting down inside the dummy and destroying instrumentation.
And to be clear, how much does this instrumentation cost inside the dummy?
The dummy that this goes on, if you bought this dummy fully instrumented, is over $500,000.
So you really don't want anything going in there?
No.
So what are some of the challenges with printing this mold? I mean, I assume that you've kind of fabricated this mold in other ways before?
Yes, this started out as a silicone mold, and it's more of a high volume. It's one of the few high volume parts that we tend to run here, and the problem is with the silicone that the silicone kept wearing out. Mm-hmm. The silicone mold had already been replaced probably 3 times within the last 3 years, I would say, and it was due to be replaced again just because it was wearing out. Mm-hmm. And I decided to take a look to see could I make a rigid mold out of the Markforged printer without having to go the step of having an outside source machine an aluminum mold. Because of the shape of the part, if this was machined out of aluminum, it would probably have to be a 5 or 6 piece mold versus a 2-piece mold, which is what the silicone is now. Yeah. So my job was to see whether I could make a Markforged 2-piece mold that would last as long as what an outsourced aluminum mold would.
So to kind of like sum it up, you found that the silicone molds, while they were small and maybe a little more cost accessible, were unworkable because this just was like too high of an application part and it was wearing out too quickly. So your options were either machine it out of aluminum or print it.
Yes.
And so with machining it out of aluminum, just a ballpark estimate, how much do you think it would have costed?
I'm going to say it would have been about $20,000 for an aluminum mold.
And is that because it's multi-part and it's because it has some fine features?
It's a very complex shape. It's round. It's got bosses that stick off of it. It's got pins. It's got steps in the part. It's just a very complex part, and it's not very big either. So you have to do a lot of really small, fine machining, which takes a lot of time and really ups your cost when you outsource it.
So how much did this cost to print?
This mold cost a little over $100 when it was all said and done. It was I want to say it was roughly like $129 of material to make this part.
And so what were some of the challenges with printing this mold? Because it's kind of a large, intricately shaped mold as well.
The biggest challenge was being able to split the part to get the part out of the mold and get the mold apart when it was done. Mm-hmm. And I spent probably 2 straight days doing nothing but working out how to be able to, where to split the part and to be able to get the part out when it was all said and done.
Interesting. And it looks like you kind of inclined the mold a little bit. Can you tell me a little bit about why you did that?
Yeah, the parts actually sits in there at about a 30 degree or 25 degree angle. And the reason for that is we pour from the bottom and we basically are forcing all the air bubbles in the part to rise up and come out the vent at the top of the mold.
Mm-hmm. So you need some kind of vertical incline throughout the part, which means you have to make the mold a little bit more specialized. So how do you think the mold turned out?
I'm very happy with the mold. I mean, we haven't made a lot of parts out of it yet. We're still going through the proving out process, but from what I've seen so far, we've got really good looking parts. The mold has not degraded at all, and I think once everybody approves of it, that I think it's going to go into production, and I expect there to be a second mold made very shortly because of the fact this is one of our higher volume parts.
Yeah. So it seems like you use kind of an interesting strategy to seal the mold together. Can you talk a bit about your captured nuts?
Yeah, all I've done is I put holes around the outside of the mold, and I've tapped those holes, and I actually put helicoils in there.
Oh, okay.
Because of the fact that this mold's going to be open and closed a lot. I was worried that just plastic threads were not going to hold up over time, so I just, before we get to the point of stripping the material out, I just went and put the helicoils in.
So are there any other interesting features of this mold you'd like to highlight?
I do have a couple dowel pins in there basically for alignment, just to make sure, because I put enough clearance in the holes to get the screws in, because as these molds get used, they're going to get thermoset that's going to get cured in areas where you don't want it, and so I like to leave a lot of clearance in the holes for the screws, but the problem is that can cause misalignment of the part. So, and I mean, the big thing is, rather than print a giant block of silicone out, I tried to keep a uniform thickness around this ring, but the fact that it's at a 30-degree angle, I put a bunch of standoffs on the bottom so that it's hollowed out and used a lot less material.
Cool. And so with that, you said something about dowel pins and precision. I want to track back to that a little bit. With silicone molds, you tend to have a problem with part seams, right?
You do. Your silicone molds, depending on how you put the two halves together, there's multiple ways of doing it. But you can have, because of it being silicone, and depending on if you have some type of a clamping apparatus to hold your two halves together, you can end up with misalignment out of your parts just because of the fact that the silicone's flexible.
Yeah, and so what do you see about that with Markforged parts? Do you see similar problems?
No, and the other thing is you get a really tight fit when you do a mold and you put screws in it, to the point where you don't have leakage and you don't really get parting lines in your part. The parting lines that you do get are usually so thin that you can just take your finger and usually rub them right off.
Yeah. And so I know silicone's a pretty dense material. Is there any difference in terms of molding time?
Molding time, I mean, some of our large silicone molds have to be heated for 12 hours to get them completely up to temperature. Most of the molds that I've made out of the Markforged printer, within 2 hours are up to temperature.
Yeah, that's really interesting. Awesome. So it seems like this silicone mold's a really cool part, and you have a bunch of other ones in your factory. But I want to move on really quick, since we only have a limited amount of time, to focus on the other part. Can you tell me a little bit about this? It's a really big part.
Yeah, it's a tall part. It's about 16 or 17 inches tall and probably about a 5-inch diameter. What it is, it's an assembly fixture for one of our leg flesh pieces, and what it is it goes inside the cavity of the leg flesh, and it basically positions the leg for when they put all of our leg fleshes are split in the back, so they have like a zipper that goes on to basically you put them around the bone and you zip them up to keep them closed, and it's for our assembly people to basically align the zipper to get the zipper positioned right where it needs to go.
Yeah. So to be clear, you're taking this vinyl molded leg piece. You're sticking this big fixture inside of it, and then you're adding zipper to the outside.
Yes, the zipper comes with vinyl strips on the side of it, but you got to get the zipper positioned right over the split that's in the leg. Mm-hmm. So what this does is this splits the leg apart, so that the width of your zipper is basically the width of the flange that's down the back, so that you know if you lay your zipper right along that flange that it's in the perfect position.
That's really cool. So I assume that you had some fixture for this before. Can you tell me a bit about it?
We did. It was a very old fixture that had been dropped a few times and had been broken and glued back together, and I'm not really sure what material it was made from, but it was a very heavy plastic of some kind. Mm-hmm. It wasn't very strong. So the assembly people had come to me and asked the question of if it was something I could make because of just the fact that it had been broke so many times. And I took it one step further, saying, well, if I use the Markforged printer, I can do the triangular infill and really lighten the weight of the part up. And after I made the first one, they were extremely happy and came back with a list of about 5 other ones that they wanted done.
So you said there are about 5 other ones. What are some other places you've kind of made these fixtures for?
Right now, we've mainly just do it for the assembly people. I've been trying to get the machining group to look at making some machine holding fixtures, and I've also been working with the QA group to possibly look at getting fixtures to hold parts for them to run the ferro across to QA some of our parts.
So you had this old big plastic part that was breaking that probably needed to be replaced. Are there any other ways you could have thought about fabricating this besides printing it?
You could have sent it out, had it machined out of aluminum, but you're not going to gain anything because the weight's going to be the same as what the existing plastic part is. Yes, it will be stronger. Yes, it will last forever. But even still, with the sharp corners that are on this part, if you drop it on the floor, even the aluminum's going to ding on a cement floor.
So with that, it looks like you're kind of trying to expand your usage of these printed tools and fixtures. I want to take a step back and ask you just a simple question. How do you think using these printed tools and fixtures and the ribs as well, how has it affected your manufacturing process?
From my aspect, the first thing I look at now is anytime a fixture comes along or any type of a mold request comes along to replace a mold, the first thing I like to do is look at the part and say, is this something that, if it's a current silicone mold, is this something that we can make that no longer has to be a silicone mold?
So of these molds, of the ones that are appropriately sized, do you think most of them are printable with our machines?
I believe the majority of what we do in-house, yes, we could make molds. A lot of our molds right now are way bigger than what they need to be. Like a lot of the silicone molds, just because of the fact that you use the weight of the silicone to hold the 2 halves of the mold closed, because you don't have the ability really to put screws in and hold the pieces together unless you were to embed aluminum plates in the silicone. The problem with doing that is when you put a thermoset mold, especially when you put it in the oven, you've got silicone that expands at a different rate than what the aluminum does, so it doesn't like to have the aluminum embedded in the silicone because it tends to expand more and it pulls away from the aluminum. Mm-hmm. So with the Markforged being able that you have a rigid outside and being able to put the screw or helicoils or threads in there and be able to screw your parts or your molds together tight makes a huge difference.
Yeah, that's awesome. So with the success you've had in silicone molding, how do you think this 3D printing technology is going to impact your workflow in the next 3 to 5 years?
I expect to see a lot more of these molds that we currently have. Rather than being replaced with silicone, we're going to start replacing them with 3D printed material.
Mm-hmm. And do you think that you're going to look to expand out of silicone molds into other aspects of the manufacturing process?
I would like to. We've talked many times about some small plastic parts that go in our dummies that aren't a critical tested part or feature. Looking at 3D printing them, they're parts that are molded now when they really don't need to be molded. Mm-hmm. And I would like to expand into actually making production parts off of the printers.
All right, so with that, I'll have one final question before we kick it to questions. What's your advice to engineers and manufacturers who are thinking about adding printing to the workflow but haven't done it yet?
You should really look at 3D printing, and it's a huge cost savings when you have these machines in-house. And it's also a huge time savings. You can look at designing molds outside, aluminum molds or even silicone molds, and you can look at spending thousands and thousands of dollars to have these machined or produced outside, or you can look at the ability to do them in house for literally tens or hundreds of dollars.
Mm-hmm. And would you say it's just worth the try, even if it doesn't work out?
It is worth the try. It is definitely worth the try.
Well, awesome. Thank you so much for your time, Chris. And with that, I'll kick it to questions.